data in order to be able to have data that's worth something. And then after you collect the data, how are you going to organize it in order to figure out something about that data? And then after that, you want to find out, analyze it. How are you going to analyze it? And what are you going to do with that data? I mean, how are you going to analyze it? What are you going to use about it? The mean, the median, the mode? And after you do that, what do you do with that? Okay, so what? I got the mean for this. What does that mean to me? Okay? So basically what we have to do is figure out, first of all, is look at the data and see what it looks like. And we do that by using graphs. So we have different graphs that we're going to be using. A statistician would use a graph, and the most likely that he's going to use is a histogram. We're going to see a lot of other ones because, there's other ones that we use. For example, if you do qualitative data, you would probably use a bar graph, and we would call one that's a Pareto chart. We'll be looking at it in a minute. But basically, you would not use a histogram. If you're wanting to show somebody percentage over something, like percentages or part over something, you probably would like to use a pie chart or something of that form. If you're in business and you want to show sales and how sales are going through time, you would use a timeline of some sort. So different charts have different functions. Now the one that we are going to be using a lot is the histogram. Okay? But we are going to use the other ones. Now I'm going to concentrate more on histograms than all the other ones because that's the one you're really going to see. You're going to see histograms again in Chapter 3, in Chapter 4, in Chapter 5. Then in Chapter 6 you'll see it as part of the other stuff. Okay? But you're going to see the histograms all throughout the course because it's the one we use most often. Now the other ones are important, but basically you're just going to get questions, very few questions from them. Okay? So let's look at this. First of all, I'm going to give you a general overview of the histogram. In order to talk about that, first of all, we want to find out the characteristics of a graph. Now, some of the things we want to know about data is we want to find a center. Okay? So center is a representative or average value that indicates where the middle of the data will be located. Okay, what is the main representative of the whole set of data? Now, all of this is in the thing that I put in your D2L account, so you should have it there. Variation. Variation is basically how spread is the data. How far apart are they from each other? Okay. Well, how far is it from the lowest to the highest number? I mean, what is its spread, basically, is what it is. Then the other thing that we want to find out is how it's distributed. Okay? Different shapes will tell you there's different types of distributions. You have different ones. There's one called a normal distribution. Have you ever seen the bell curve? When people say, are you curving that? That's basically, they're talking about the bell curve. You have other ones. If you go into any kind of medicine or nursing, or if you go into biology, if you have to take A&P, you'll be looking at one called the chi-square distribution. So like a hump like this. So different data have different types of distribution. Then we want to find out outliers. For example, if you ever remember, sometimes we'll say things like, well, the average income in East Tennessee is $95,000 a year. And you think, well, I make $35,000, my neighbor makes $25,000, my other neighbor makes $37,000. Where in the world do they get that number from? Well, people who make huge amount of money will pull those numbers out of shape. Okay? We'll pull those numbers higher or lower. Okay? That's called an outlier. So we want to find out, we want to identify outliers. Okay? And some of the graphs will tell you that. And then some graphs will tell you time, how the data is going through time, going over time. So basically you have data and you want to find out some of this stuff. So we have different graphs for that. Now the first graph is called a histogram, and the histogram represents a frequency distribution. Now this is important because a frequency distribution will be throughout the whole class. You're going to have that through that whole class. Now we're going to rename them. Okay, it's going to become different things each time. That's basically the same thing. Well, we're going to change its name. Now, frequency distribution, what is frequency? How many times something happens, right? Well, basically, what a frequency distribution is, it tells you, you have a variable, and then it tells you how many times that variable occurred, okay? You don't have to read that whole thing or write it down. It's just basically that. Now, in order to do a frequency distribution, we're going to do a frequency table. And I'm going to tell you how to do a frequency table. Now, we're going to go real quickly on this. This is just data. This is just basically data that you do. And basically, we put it into classes, or these are classes right there. We have the numbers into classes, and then we count how many numbers fit into each one of those classes. Okay? So we partition the data into classes, into groups, and then we count how many numbers fit into each one of the groups. Okay, now, let's look at this again. Lower class limit will be your lower numbers here. Those are your lower class limits right here. Can you see that? So what would be upper class limits? Right, the other ones. These right here are your upper class limits right there. Okay, now let's talk about class boundaries. Class boundaries are basically, we're going to be moving these classes a little bit farther out in order so that they touch each other. Because that's what you're going to be doing. They're going to be touching each other. What happens is that this number and this number are going to become the same. The way we're going to do is we're going to average these two numbers, and we're going to put them here and here. In other words, what's going to happen is, in order for a histogram, the walls have to touch. You might want to write that down. On a histogram, the walls of the bars have to touch. On a histogram, the walls of the bars, the actual bars that you're doing, have to touch. And it's the only reason for class boundaries. It doesn't change your class limits. Your class limits are the same. It's just that now you have to have, you're going to write it down on paper, you're going to draw it out on paper, and those class walls, those walls right there have to touch. And if you did it 69 to 70, there would be one space there, one point, where it wouldn't be touching. Okay, there would be a gap there. A gap right there. So if you take an average here and an average there, now they touch. So what you're going to do is you're going to take the averages here of the upper and the lower limit, and they're going to become the class limit here and the class limit here. I mean the boundaries, I'm sorry. The upper boundary here and the lower boundary there. But that's boundaries. Okay? So when we talk about class boundaries, we're doing that. You take 69 plus 70 and divide it by 2, you get 69.5. If you take 79 plus 80 and divide it by 2, you get 79.5. We'll work that out again. And, really right now I'm giving it an overview, but we'll do it in more detail. Class midpoints. Well, you've probably seen histograms a lot in newspapers and things. Histograms are basically those bar graphs you see, and you've probably seen them in magazines or just newspaper. A ton of them. There's tons of them. But you see them like this, right? It's like this. Right? You seen something like that? Newspapers and stuff like that? Where you have like, here's 3, 4, 5, 6, 7, and 8 or whatever. And then you have 10, 20, and 30, and 40, and 50, and 60. You've probably seen something like that somewhere in a newspaper, representing some kind of data. Now, what happens is, instead of having classes, the class limits, we want to represent it with one number only, instead of these two. So what we do is we take the midpoint, the middle number, the middle value, the midpoint. So how do we find the midpoint? Well, we take the two numbers, the two class limits, the upper and the lower, we add them together and divide by 2. So we take 60 plus 69 and then divide it by 2. 70 plus 79 and divide it by 2. 80 and 89 and then divide it by 2. So we're adding them together and dividing it by 2. Now I'm going to repeat all this again, Okay, so don't worry if you're like, hey, let's go real quick there, real quickly. Okay, so basically those are the midpoints. Now the class width. Now, this is the reason I want to approach it this way first. You're going to see it a lot in a different way, how to find the class width, when you're constructing a histogram, or when you're constructing a frequency table. But on the final exam, what they're going to give you is, they're going to give you the frequency table or the frequency histogram. They're going to give it to you already. And from there, you have to find the class width. You understand that? I mean, like, they're going to give it to you. It's given. And then they're going to say, okay, what's the class width? So that approach is different. When you want to do it and find the class width, what you want to do is take two limits and subtract them. 70 minus 60, that gives you what? 10. So your class width is going to be 10. So the way you do it is you find two sequential limits, subtract them, and that gives you your class width. Now when you go to the final exam and they give you that histogram or they give you that frequency table, that's what you're going to do when they ask you what is the class width. Okay, you're going to take two sequential limits. You could even take them here. Take 79 minus 69. What are you going to get? 10. You can even do it with midpoints. Take two sequential midpoints and subtract them. You're going to get the same thing. You're going to get 10. Okay? So, like for example, let's go back to the midpoints. If you go back to the midpoints right here, take 74.5 minus 64.5. What do you get? You get 10, right? So that's how you get class width when you're already given the histogram or the table itself. Okay, any questions on that? What I want to avoid is this. When we have raw data, we're going to have to figure out how to find the class width. And that's going to be a different way to find the class width. But when they're already given this to you, that's what you do. You subtract two numbers, two limits, or two midpoints, and you get your class width. Okay? Okay, now, the other thing we have is, okay, well, this is just telling you that. The difference between two consecutive lower class limits or two consecutive lower class boundaries. Okay? Okay, now, why we want to do frequency distributions? Well, it's a way to figure out, it's a way to show somebody, or a way for us, as statisticians, to be able to see what the shape of the data is. Especially if you have a lot of numbers. Basically, if you have a lot of numbers, you need to do this. If you don't have any numbers, you really don't, it's not really worth your time. You would do a stem and leaf plot or a dot plot or something like that. But a lot of times you have a lot of numbers. And it's much easier to do it with a histogram. Now, unfortunately, what we're going to be doing is using Excel, or we're going to be using our calculators to do the histograms instead of Minitab or SAS or SPSS or something like that. Those other statistical software, all you do is you just enter numbers on the list, click a icon or something, and voila, there it goes. You got it. Okay, unfortunately we can't do that. But basically we want to summarize the data. We can analyze the nature of the data. That means, is it skewed to one side? Does it look normal? And usually a lot of times that's what statisticians will do. Okay, they want to find out if the data is normal. Okay, they want to figure out if it's a normal distribution, or if it's a chi-square, what kind of distribution does the data fall under in order to analyze the data. Then we have a basis for constructing important graphs. In other words, the histogram. That's what we're talking about. Okay, now these are the processes to do it. This is the procedure. Now, you will be given how many classes you will have. Okay, that will be given to you all the time. But basically, what you want to do is, first of all, determine the number of classes. Like again I said, that's going to be given. Okay? You won't have to do that. Okay, the next thing you have is, we want to calculate the class width. Now remember I told you that you have sequential limits? Well, this is with raw data. Let's say that you have raw data, just numbers. They gave you a bunch of numbers. Well, what do you have to do? Find the lower number, the lowest number you have, and find the highest number that you have and subtract them. So you subtract them, and then you divide by number of classes that you have. After you do that, you get your class width. Okay, now here's where somebody asked me about rounding. You always round up. And how do you round up? Okay, if your data is whole numbers, you round to the whole number. If your data has 10th place value, you round to the 10th place value. If your data has hundredths place values, you round to the hundredth place values. You see that? And you're always rounding up. So, for example, if it said, if you're, when you did the class width, you got 3.15, and you wanted to round to whole numbers, it would be 4. Okay? Now, if your data had 10th place values, it would be 3.2. So you're rounding up to whatever decimal place value your data has. You're looking at your decimal place values on your data. Now, after that, you're going to start at some starting point. Now, some people like to start below the minimum number, and some people like to start at the minimum number. Okay? So that just depends. Choose the minimum data value or a convenient value below it as the first lower class limit. Then, you're going to use that as your first lower class limit. Now, you're going to add the class width to get to the next lower class limit. Now, that's important. You don't add it to get the upper class limit, you get it the lower limit. For example, you're going to have this. Let's say that your lowest number was 32, and your class width was 10. You add 10 to 32, and you get 42 down here, not up here. It goes down here. Then you add another class width, and you get 52. Then 62. So you're adding the class width each time to go down to your lower limits. Lower limits then. How do you find the upper limits then? Well, we take 1 from this one. 42 minus 1 gives you what? 41. 52 minus 1 gives you 51, right? 62 minus 1 gives you 61, and so on, right? So, and look at this. 41 plus 51 minus 41 gives you what? What's that going to be? 10. It's the class width, isn't it? So what you can do is do the first one and then add the class width each time to get the other limits. You see that? Now, that's going to be important. So you want to find the lower and the upper class limits that way. That's what that's doing right there. After you do that, after you find your classes, what you're going to do is you're just going to count. You have your numbers. You say, okay, how many numbers go between 32 and 41? You count them, and that becomes your tally, or your frequency right there. So let's say you have 3 numbers that are between 32 and 41. Maybe it's 33, 36, and 40. 3 numbers. So you're just counting them, and you're tallying them inside of those classes. Okay? And that becomes your frequency distribution. That is your frequency distribution. Okay, now this is an overview, and I'm going to have about 3 examples that we're going to go over. Okay? However, I'd like to give you a break of 10 minutes. So go ahead and take 10 minutes, and then when we come back, we'll give you an example. Okay?